Good morning, everyone. For this morning, I will discuss problem solving heuristics, when to use it and its importance. Then later on, my group mates will discuss also the search for a pattern and formulate conjectures as part of heuristic approach. So let's start the lesson by defining what is a heuristic. It is a term coined from the Greek word euriskin, which means to find or to discover. So basically, the word heuristic is serving to find out or discover. Heuristic is also known for its rule of thumb strategy. It is the principle you follow, which is based only from past experiences. That's why it's sometimes called a mental shortcut. You only make decisions based on them rather than performing calculations or doing a step by step process or procedure. The methods of heuristics results in a quick solution but sometimes lead to errors. So I'll give you an example for this. For example, your family is in a hurry to go to the park, but you've noticed the sky is full of clouds. So you decided to bring an umbrella. After a few minutes, when your family arrived at the park, the rain started to fall. Example 2. The day after, your family decided to go to the park once again. There are still visible clouds in the sky. Then you remember that yesterday was a cloudy day and was raining. You bring your umbrella, but this time, not even a single raindrop fell to the ground. So, what's the difference of these two examples? Both examples have what we call the rule of thumb. Everyone knows that when the sky is full of dark clouds, it is going to rain, right? So you come up with a decision without taking any further steps or methods to bring an umbrella. You derive that decision because of your intuition that it is going to rain. Then that is what we call a heuristic problem solving. You made a very quick decision based on the rule of thumb. In the first example, your decision to bring an umbrella is the right decision. No errors found in your decision. But in the second example, you come up your decision to bring an umbrella because you used your past experience from yesterday that it was raining, which is wrong because in the current situation, it does not rain at all. That's the reason why heuristic problem solving strategies sometimes lead to errors. There are different types of heuristics can be found in the internet, but I have here the most basic ones. First is the availability heuristics. It is making decisions based upon how easy it is to bring something to mind, only relying on recent accessible knowledge rather than evaluating the facts. An example for this would be when you're going to the beach for swimming, then suddenly you remember the news you watched last night about shark attacks. So you didn't go for swimming. You make decision based on what your mind remembers about the past experience or knowledge. The second type is the affect heuristics. You make decisions based on the influence of your emotions or your reliance on your feelings. For example, you're in a bad mood, then you get angry to the people around you, even though they did nothing. Last is the representativeness heuristic. The word representativeness is in the reference to the notion that when we are confronted with a new experience and need to make a decisions about the situation, our brains automatically rely on the mental representation similar to this situation. An example would be when you see a tattooed man in the street and you judge him quickly as a tambay or a rule breaker, but then he is a professional tattoo artist. You judge him as a tambay or rule breaker instantly because it is our mental representation that every tattooed man is a tambay. So the usage and importance of heuristic. It is useful when facing a solving problems and in decision making. People use heuristics as a type of cognitive laziness to reduce the mental efforts required to make choices and decisions. People also use heuristics because they can be fast and correct in certain contexts. Some theories argue that heuristics are actually more accurate than they are become errors. So in mathematics, heuristic is a shortcut in solving math problems. For example, the acronym FOIL, if OIL, is used when expanding algebraic expressions. Another acronym is BEDMAS, BEDMAS, stands for brackets, exponents, division, multiplication, addition, and subtraction. Is used when solving an equation with multiple operations. Other examples are draw a pattern, make systematic list, look for patterns, guess and check. And the most basic heuristic used in math class is the trial and error.
So let's continue our lesson. So heuristics, pattern, and conjectures. So what is pattern? In mathematics, patterns are a set of numbers arranged in a sequence such that they are related to each other in a specific rule. These rules define a way to calculate or solve problems. For example, write a conjecture that describes the pattern 2, 4, 12, 48, and 240. Then use your conjecture to find the next item in the sequence. So step 1, look for the pattern. So for the sequence 2, 4, 12, 48, and 240, the pattern will be 2 times 2 is equal to 4. So our first term is multiplied to 2, then the result will be the second term, which is 4. So next, 4 times 3 is equal to 12. So 12 will be our third term. So next, 12 times 4 is equal to 48. Therefore, 48 is our fourth term. Then 48 times 5 is equal to 240. That is why 240 is our last term. So that is the pattern. Step 2, make a conjecture. So the number are multiplied by 2, 3, 4, and 5. The next number will be multiplied by 6. So it will be 240 times 6 is equal to 1,440. So our sixth term will be 1,440. And that is our answer. Next, what is a conjecture? So the Latin roots of conjecture translate to throw together, which means that we are throwing together many observations into one idea. Conjectures are unproven claims. Once someone proves a conjecture, it is called a theorem. In mathematics, a conjecture is a mathematical statement which appears to be true but has not been proven formally. A conjecture is a good guess or an idea about a pattern. For example, make a conjecture about the next number in the pattern. 2, 6, 11, 17, and so on. Since the terms increased by 4, then 5, and then 6, so our conjecture will be the next term will be increased by 7. So it will be 17 plus 7 is equal to 24. So 24 will be our next term. So let's test your understanding. Let's have this activity. Write a conjecture that describes the pattern 5, 10, 30, 120, and 600. Then use your conjecture to find the next item in the sequence. So number 2, make a conjecture about the next number in the pattern 3, 5, 8, and 12. So write your answer in a clean sheet of paper, and other direction will be posted in our group chat. So there are four types of conjectures. These are understanding conjectures, evaluating conjectures, testing conjectures, and writing conjectures.
So let's proceed to understanding conjectures. We seek to understand a conjecture at three levels. We want to determine its meaning. We want to identify reasons for why we might believe the claim to be true. And we want to understand how it fits within some larger set of ideas. The initial steps we take when exploring a conjecture are similar to those used to understand a definition. So we know that a conjecture is an opinion or conclusion formed on the basis of incomplete information. Not all conjectures are ultimately confirmed to be accurate or incorrect. It was eventually demonstrated that the continuum hypothesis, which seeks to determine the relative cardinality of some infinite sets, is undecidable or independent. So let's proceed to evaluating conjectures. There are three characteristics of evaluating conjectures. So first, most conjectures are formed through inductive reasoning. Pattern and property recognition are extremely important mathematical skills, but they do not always lead to valid conjectures. And last, to disprove a conjecture, providing a single counterexample. So let's give an example. 2 squared minus 1 squared equals 3. 3 squared minus 2 squared equals 5. 4 squared minus 3 squared equals 7. So, last is the 7 squared minus 6 squared equals 13. So, there is a missing part in that we are going to find. So, our conjecture is the differences of consecutive squares is always prime. So that is our conjectures. So let's see if this is true or not. So the next pattern that we form is 5 squared minus 4 squared equals 9. So the result, which is an odd number but not a prime number, because 9 is a perfect square, so the conjecture that we formulate is false. So if we encounter this kind of example, it is called the counterexample. Counterexample is a simply any example that invalidates a conjecture. So our counterexample here is 5 squared minus 4 squared equals 9.
So, what is this testing conjecture? Testing conjecture. The first question that we face in evaluating a conjecture is gauging whether it is true or not. So, we hear it from the previous reporter that these conjecture are the unproven claims. So from the word testing is we are going to test these unproven claims if it is true or not. And while confirming examples may help to provide insight into why a conjecture is true, we must also actively search for counterexamples. So in order to determine if that conjecture is true, we must also search for the counterexamples. So what is this counterexample? A counterexample is simply an example that proves that the conjecture is wrong. So it is used to prove this statement that it is false. One way we can develop this skepticism is by giving students problems that have false patterns, ones that seem familiar but do not continue as expected. So, for example, here's an algebraic equation and a table of values for n and t. For example, t is equals to n minus 1 times n minus 2 times n minus 3. So, we will put in the table the n, which is the n input, the calculation, and the t, which is the output. So, for example, our conjecture here is for all n, t is equals to 0. So, for example, we will put 1 to 3 in n. So, in 1, we will replace n into 1. So, 1 minus 1 is equals to 0, 1 minus 2 is equals to negative 1, and 1 minus 3 is equals to negative 2. So, if we calculate it all, the result is 0. So, same as in 2, we will replace n into 2, n minus 1 or 2 minus 1 is equals to 1, 2 minus 2 is equals to 2, and times 2 minus 3 is equals to negative 1. If we calculate it, the result also is 0. So also in 3, we will do the same. The result also is 0. So for this calculation, we can say that this conjecture here in above the table, we can say that it is true. But here we will use a counterexample which we will make that statement or that conjecture is wrong or false. So, example, we will put it here in n as 6, for example. So, we will replace n into 6. 6 minus 1 is equals to 5 times 6 minus 2 is equals to 4 times 6 minus 3 is equals to 3. So 5 times 4 is equals to 20, and 20 times 3 is equals to 60. So by this counterexample that we used, we prove that the conjecture in the above mentioned is false. So, the conjecture here is false.
And now we proceed to writing conjecture. Writing conjecture, for students, there is often a wide gulf between the ideas with which they can grapple and their ability to write a clear statement of their thinking. They need to learn the mathematical vocabulary and formal structures that make writing a logical claim easier. Example. First, we need to look for a pattern. And the example below is Carmen uses the letters in her name to form a pattern below. So the letters are Carmen, Carmen Ka, and so on. And the question is, what will be the 405th letter in the pattern? Solution. First, we need to understand. And what to find is the 405th letter in the pattern. And what is known, the pattern is formed by the letters CARMEN. The pattern starts repeating itself from the seventh letter. Number 2, look for patterns. Number 3, solve. Carmen is the repeating block of letters. There are 6 letters in each block. So we need to divide 405 divided by 6 equals 67 remainder 3. So there are 67 such block and remainder of 3. So we need to count more 3 letters to determine the 405th letter in the pattern. So the 405th in the pattern is the letter R. And before we go, we need to check it first if our answer is correct or wrong. So 67 times 6 equals 402, and 402 plus 3, the remainder 3 equals 405. So we can say that our answer is correct.